And then basically you kind of stick a pole right through the center of that. Okay? And that's now going to be your z-axis. So a lot of times you'll see people go like this. Have you ever seen that when you learn about 3D? So you can think you have your x, y, and z-axis when you want to think about it. Okay? Can you see that? We have that plane. So now how many regions? So we don't have quadrants anymore. We have octants because there are how many regions broken up? 8. So you have 8. So you can go in the positive, 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 positive x, positive y, positive z, or positive, positive, negative. So show me where positive, positive, negative would be. Positive, positive, right? So you're over here, and then you're negative. So it'd be like there. Does that make sense? So each finger's up. Let's try this. Okay. Show me where a positive, negative, positive would be. So we're going to go positive, negative, positive, right? Okay. So see if you guys could try negative, negative, negative. Talk it out. Negative, negative, negative. I'm going to go down. Okay, so you got a little bit of an idea of how you're moving?
Oh, should I?
See if it,
Vector.
see if it works this time. I know, such good clips about vectors.
Okay.
So again, we were kind of already doing this. Okay, X, Y, Z. So now we're going to have our distance formula. Is it that bad? No, all you do is add on the change of z-squares. So let's find the distance between these 2 points. Go for it. So easy in algebra. Do this one so that you're fine. What? Oh, yeah. No calculators, really? Maybe it's okay. Simplify it. 6 what? Questions? Okay, so then you can kind of think to three-dimensional equation of a sphere. So now instead of just having like a circle with your x's and y's and your radius, which you're going to tag on your Z. So this guy right here is going to be your center, just like it'd be the center of the circle. So a lot of times to help us find the center, if you know 2 points on the sphere, to find the center, you're just going to use your midpoint rule. So it's exactly like we knew before, but now we're tagging on the Z. Everything is just basically like before, but tagging on a Z. So I want you to find the standard equation of a sphere that has these endpoints as endpoints of a diameter. So what can you use those endpoints to find? The midpoint, and what else could you find? The distance would be the what? Diameter, and then you'd have to divide it by 2 to get the radius. You want to try it?
Yeah.
All right. Everybody get that for the center? Okay. So you could do the 2 points to do the diameter, or you could go from the center distance to a point to get the radius, whichever one you wanted. So you could get that diameter by finding the distance between those two, or you could go from the center to the end point to get the radius. I would choose to find the diameter because you don't have what? Fractions. Okay? So I'm going to say the diameter. So I don't have all my negatives. I was just doing the change of them absolute value. Since you're squaring them, do you have to worry about the negatives as much? No. So just kind of making life easier. Kayla, when did you get here? Oh, go ahead. Tell me when you get it. 98? Radical 98? Is that what everybody got? Okay, so that's the diameter. What did that simplify? 749 times 2, so 7 radical 2. So that's the diameter, so our radius would be, you really don't want to simplify it though, because you're going to end up squaring it, right? Oops, sorry, I know all of these. So your radius would be radical 98 over 2, or you could say 7 radical 2 over 2. Is that part okay? So now plug it all in to get the general standard, standard equation of the sphere. So x minus 5 half squared plus y minus 1 half squared plus c squared equals radical 98 over 2 squared, which would be 98 over 4. What's 98 over 4?
24.5.
49 over 2. Okay. questions? Is that okay? Huh? More, please. May I have some more, please? All right. So, don't look down at your notes. Don't look down at your notes. Just think about this, right? Back in two-dimensional, Mason. Now you can think about it. Okay. Back in two-dimensional, what are some standard unit vectors in the horizontal direction? What's the standard unit vector?
X, horizontal.
Yeah, what's the standard unit vector?
I and J.
And what's I?
I is the horizontal.
Which is what?
The first.
Like, what's the vector in component form?
I, comma, J.
No.
I plus J.
Help them out. 1, 0 in that vector form, right? So back in the day when we were in 2D, I was 1, 0, right? What do you think it's going to be in 3D? 1, 0, 0. All right? So that was in the horizontal. What about in the vertical? Yeah, 0, 1, 0. So now we're also going to have in the Z direction, right? Now it is I, J, K. And that's going to be what? 0, 0, 1. All right. So here we have these guys that we just talked about. So those are the standard unit vectors. We can find the norm or the magnitude of the vector. Again, it's exactly what we did, and then we just tagged on that extra component. Okay. We can write that component, so like if I had vector v1, v2, v3 in component form, we could write it in a linear combination or standard form with I, J's, and K's now, just like we did in 2D. Is that confusing or is that okay? Thumbs up, thumbs down. Show me. I don't see a thumb. All right. So let's see. Find the component form and length of the vector v having this initial point and this terminal point. Then find the vector in the direction. Find a, sorry, this is supposed to say unit vector in the same direction as v. So let's just first find vector v. How do we find it if we know terminal and we know an initial? Terminal minus initial. All right, so find vector v. Did you hear me saying that a lot yesterday? Now you know why. Are you guys alive today? My goodness. Here Michelle's a guest visitor, and you guys are usually like, ah! She's going to think, oh my, I never want to do this.
It was really fun class there.
I know. Skylar's sick. Is that why we're all upset? Two negative 13, 4. Did you get that for vector v? All right. Find the length of vector v. Find the magnitude. If you haven't already, go ahead. your calculators out for this one.
It's off. I don't know what you're talking about.
Okay.
I have a calculator over here.
Are you ready to get that?
I think it's the evidence.
So now finish. Find a univector in the same direction of V. Talk in your group if you forget what to do. We did this yesterday. You're good for your notes? If you want to verify, you can. Oh, yeah.
Is it like something parentheses, brackets, and braces, and so they call it no, carrot is like the brackets either don't really like a square parentheses and ones that have the
How'd you guys do? Did you get that? I rationalized. Just so
you don't like that.
saying in mathematics. Like that.
Row unit vector.
You can. You want to write it? So this is in what form? Component form. If you wanted to write it in standard form, what would that be? Let's go, James.
2I minus 13j plus 4.
That's for V. So this was 2 vector I minus 13j vector k.
What is this going to be?
Okay. Did you rationalize?
Yeah, I tried.
Have to.
Well, it's the graphic 21.
Hard.
It's the graphic 21. 2 divided by graphic 21 would be 2 bracket 5 over 60.
So this would be radical 21 over 63.
But yeah, multiply by 2.
Because I can do that. So this would be, let's go ahead and fix that. That's what you guys are supposed to be doing. Does that look better?
Yeah.
Well, there's the other ones.
Did I mess up on all of them?
So, yeah.
No, you did rationalize! Alright.
Wrote it down. It was
Exactly. Lesson learned right here. I was just trying to teach Mason a lesson, that's all. Alright, so this was what? Radical 21 over 63. Or radical. Look better?
Yeah.
Okay.
you.
Okay.
You had I, J, K.
Right. If if you wanted to. It didn't say what. Oh, it said component form up above. So the second one just said find a unit vector, so you could have done it either way. Okay? You could have had with ij's and k's, or you could have just left it in component form. Okay. Ooh. Lesson learned, Mason. Oh, that was just for you. Parallel. Two vectors are going to be parallel if you can just have some scalar c that when you multiply by, you just get the in the same direction. So like if I had a vector like this, and when I multiplied by c, maybe it looked like that, or maybe it ended up looking like this, right? And you multiply it by negative c or something. All right, so they're going to all be parallel if you can just multiply by some c. So basically, if you could factor out a c and see that you have the same thing, then that's parallel. Okay. So example, vector v has an initial point and a terminal point given. Which of the following are parallel to vector v? What's the first thing you'd want to find? Vector v. So we're going to do 6, 1, negative 2. Is that in your notes? Like that, 6, 1, negative 2. Okay. Courtney, what'd you get for B?
All right, Mickey, you let Caitlin Warren know she has something to pick up here at the Trojan.
Okay.
Thank you.
What's that, Courtney? You got negative 10?
Yeah.
Negative what? So let's see if any of these are parallel to vector b. So let's see, what would I have to multiply v by to get to m? 10v? So 10v would equal what? Negative 100, that's good.
Be like that, yeah.
Negative 10, that's good. Oh, and then I get out 10, and these don't match, so is this one parallel?
Porque.
So m's not parallel. Okay, well what could I multiply v by, or n by? You could go either way. You want to multiply by n or multiply with something by v?
1/10.
Alright, so we're going to take 1 over 10v. What would that give me? Yeah, it's just I'm picking some scalar to try to get it to be equivalent. So I'm definitely going to pick one where the first terms are matching. So I could have also said I'm going to take 10 times n and see what I get. See if I get out v. Does that make sense? As long as you just have some scalar times the vector, and if you could get it to be equivalent, they are parallel. Okay, so this was negative 1, negative 1/10, and then 1/10. Ding, 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 ding.
We have a winner.
Okay, so these guys are parallel. Is that what you wanted? Parallel? Okay. We're almost done. Alright, so we just... Yep. Which of the following are parallel? Determine whether these 3 points lie on the same line. So if they lie on the same line, then they would be parallel. But I got 3 points. Do I have vectors? So I could say I could start here and go out to here and create a vector.
And then you can start somewhere else and create another vector.
Well, do you want to start somewhere else?
Yeah, you just
Think about like if you're trying to start somewhere, right? And you go out to there, do you want to start somewhere else and see what you're doing? You want to start at the same point and see if you get it, right?
Yeah.
So I could go from P P to Q and find that vector. And then what else could I do?
Go P to R.
P to R and find that vector. Could I have done Q to P and Q to R? Yeah. Could I have done Q to P, or sorry, R to P and R to Q? Yes. So let's go ahead and find those and see if they're parallel. Because we'd have to start at the same point. What do you want to start at Q?
We couldn't.
Only, okay, so you could do that, or you could have done Q to P, but you'd have to compare it to what? Q to R is what I'm saying. Okay? Okay, so are they parallel? So why are they parallel?
P and Q by 2.
Since they have common points and what can you say? PQ is equal to what? Guys, PQ is what? Equal to what? It'd be what? 1/3 PR? Or you could say PR is equal to 3 PQ. Does that make sense? They are parallel. Huh? Yes. Okay. So yes, they lie on the same line. So they have the common point and parallel, so they lie on the same line. They have the initial common point, and they are parallel, so they lie on the same line. See if anybody in your group has questions over that.
Got it.
Okay. First thing I want you guys to do for homework is this page, this one right here in your notes from the book. I have 2 up here. Okay. Then you can start on the rest of your homework and have fun.